let's move on to the next team. So next up, we have a tool. It's a team that saw a problem in learning tonal languages, and spent the last 2 weeks really creating a fantastic solution to this problem. Yeah, there's not much more to say. I'd love to hear what the team at Intone can tell us about their app. Go ahead.
Hi everyone, I'm Pimpilla, and I'm here with Mike, Mark, and Edmund, and we are the developers behind Intone, an app that helps people learn tonal languages. Now, the difficulty with tonal languages is that it's really hard to hear the difference between tones and to reproduce them. For example, in Thai, ma means horse, and ma means dog. And many of you are probably thinking that they sound exactly the same. So that's where our app comes in. Users are given a series of vocabulary flashcards where they can listen to a clip of a native speaker's pronunciation of the word.
Bye.
Then they can record their own attempt at the word and play it back.
Bye.
And they are then shown a graph of pitch values over the duration of the word stacked up against that of the native speakers. And up next is Mike to talk about how we captured and analyzed that data.
Thank you, Pim. As Pim explained, tonal languages rely on pitch variation over short periods of time. That's what a tone is to distinguish the meanings of words. So not only are they difficult to perceive, they're actually kind of difficult to reason about. So the first thing to understand is kind of the representation of a tone. So above you have a waveform. You actually can't perceive it because it's not actually giving you the full frequency range. So with a spectrogram, you can actually see the pitch contour, which is actually just a set of data points. So we were actually able to just treat it as an array. Each data point is the fundamental frequency for that given sample of the audio data. So applying pitch finding algorithms to an audio data can actually just give you an array of fundamental frequency values. So we found that once we had these, we had to construct an apparatus that could record audio, playback audio, create the contours on demand, and then we actually had to figure out a way to compare them and give the user feedback. And speaking about the next is Mark.
Thank you, Mike. So one of the challenges that we faced in designing our study component was displaying all the information in a way that could be easily understood by our users without showing an overwhelming amount of information. And our solution to this was to calculate a score for each attempt that a user made. And what the score could do would kind of create context for the generated pitch contours, as well as incentivizing users to continue to improve their performance and continue training. And so these scores are generated by measuring the change over time for each pitch contour and then comparing the differences to ascertain similarity. And so once we had these scores generated, we kind of opened the door for more metrics that a registered user could view by navigating over to their profile page. The default view, as you can see, shows a brief synopsis of a user's profile, as well as every word that a user could attempt for a language. This can further be filtered by tone, where users can kind of see their best attempt at a particular word in a particular tone type. And here we retrieve all of the best target audio and the best graphs that a user can kind of listen to, and from there make the decision on which words and which tones they want to improve upon. So this itself was a challenging component to make. So now I'll pass it on to Edmund to kind of walk through a bit of the data flow for Intone.
Thank you, Mark. To my side here are all the technologies that we use to build this app. And very briefly right now, I'm going to talk about how we were able to take in the human voice as an input and then render out as an output various statistics about user performances. The first thing that happens is that when a user logs in, our Redux store is populated with data from our database about their previous performances. Second, when a user goes to the study component and hits the record button, we use the very cutting-edge Web Audio API to create an audio context and analyzer nodes and produce from their voice an audio blob. Third, we send that blob up to our Redux store, and as soon as it's in the store, our graphing component, which is also in our study component, pulls it down. And fourth, passes that audio blob through about a half a dozen audio processing utility functions. Some of these we were able to find on NPM, and others we had to develop ourselves. One of them is the comparator function that Mark was just talking about a moment ago. Fifth, we send that data back up to our database, and if that current performance was the best of all previous performances for that target tone, we put a flag in our database and lower any previous flag for that tone type. This was a lot of fun. There were many challenges in this project, but we had a blast hitting them all head on, tackling some of them and still working through others. Please check out our app. We're very excited about it. Thank you for your time and attention.
Very impressive. We hear a lot of talk these days about how technology is kind of making us less human and all that's all that kind of that sentiment. But I feel this is a great example of how we can use technology to understand humans better, to make something that's so personal to people, which is their own language. Let people learn other human languages better, and use data and statistics to do that.
As someone who struggled with tonal languages, there's 4 tones in Chinese, can't get those. 5 tones in Thai, can't get those either. And it's cool to see the visualization. I've never, because it's kind of like teaching someone how to program, but not being able to show text. I've had so many Chinese instructors like, you just say it like this, and I'm like, that makes no sense, So to see it visualized out is really cool. Also, to me, like this project, the last project, to see the web audio stuff that everyone's doing in the browser, that's crazy to me. Like 10 years ago, could you imagine people would be doing FFT analysis in browser? I just didn't think that would be possible. So
it's amazing.
Yeah.